Hello there, welcome to my talk. I'm Cheuk, and so I guess you're here today because you want to learn about what uh, standard library can offer you to do. What is included when you install just the vanilla, just the Python interpreter itself from the official, python.org. When you install Python, there's actually a lot of things that are included that you may not notice that exist. So this talk, I'm gonna show you all of them. So here in the slides, there's my contact detail. I'm happy to chat with you if you have further questions about that, or if you want to have anything Python related that you want to talk to me, then you're welcome to to find me with all those links. So to begin the talk, I would like to introduce myself because this is my first time in PyCon Latam. Because it's very exciting for me. Since this year is online, then that's why I can be here and to be able to give this talk. Who I am? I'm Cheuk. I based in London. I am very enthusiastic about open source project. So I started publishing my open source project a few years back, and then since then I've been involved in different open source projects, including my job at the moment. I'm so lucky to be working for an open source graph database project, Terminus DB. So it's open source, it's a database. I love data handling. So if you're a data scientist or a data engineer alike, then feel free to talk to me. I'm happy to discuss furthermore what a graph database can do for you. I'm also an organizer of different Python events. Locally, I like organizing meetups and sprints where people sit together and contribute to open source projects. I also organize conferences like Your Python and PyData Global. I'm helping out this year again. Yes, I helped out last year and help out this year again. And also there is a Pyjamas Conf, which is a 24 hours non-stop online conference. It was a very exciting things going on last year. So everybody was happy joining this event because this is the laziest Python conference ever. Everybody just sit at home, drink a hot chocolate or whatever that make them feel comfortable and watch talks live streams. So it's fun. Hopefully you can join us this year as well. Talking about streaming, I also love streaming myself. I have done that for a period of time in the past. Right now I'm taking a break, so I'm not streaming very frequently anymore, but my recordings are available on my YouTube channel. Feel free to go there and check it out. So back to the standard library thing. So this actually happened to me in real life. I used to work in a bank before as a data scientist, but now just imagine that you work in a bank. That because a bank is where people put their money in, right? So the computer system is very important. If there's someone who is the bad guys can go into the bank system, they can steal all your money. So we don't want that to be happening. So the bank computer system is highly secure. So lots of things you can't do when you work in a bank and use the computer there. First of all, you can't install anything without the permission. Because if all employees can install whatever they want from the internet, someone who may not be very technologically advanced may install a malware that can damage the whole system, which create a security problem. So we don't want that. Also, there are limited access to the internet. You can't connect your computer through your mobile phone network. I know that sometimes we do that when we go to a cafe or go to somewhere else. Then there's no Wi-Fi. Then you can connect through your phone, which is very convenient, but you can't do that in a bank. Also, you can't use your personal laptop to do the work thing. So So in your work computer, you're only given a vanilla, which is purely just Python 3.6. It's not even Anaconda. I know that data scientists love Anaconda, and it's not the case here. So it's only Python 3.6. So what can we do? Let me show you that actually you can still do a lot of things because you have the standard library. So standard library are actually libraries that come with the official installation of Python from the python.org, the official website. So there's actually a lot of things that you are not aware that is included, which in this imaginary scenario could help you out. So what are they? What is included, right? So actually a standard library, surprisingly, is quite a big library. There's a lot of things that are included that you may not notice. Some of the modules, they will be written in C. So if you want to have a look at what they are, you can actually go to the GitHub for C Python to have a look. But they will be written in C for these modules. So you have to have some knowledge in C to be able to poke around and and see what's going on. Usually these are the libraries that provide these are modules that provide some system functionalities, like for example, OS it works together with your operation system and sys. So a lot of them that are actually including the path of your computer, right? So it's your system, it's your operation system. Also maybe sometimes the file there, or sometimes that actually to access something that is your operation system. So they need to be more low level, so they're written in C. But outside of that, there's also a lot of modules in the standard library that are written in Python. So the purpose that they exist is because there are a lot of things that you can do in Python that are quite common tasks, right? You don't want to reinvent the wheel. So for example, I'll use a math module as an example. A lot of people need to calculate stuff in, for example, in the research, right? So no one wants to write a sine cosine function just every single time they want to do some geometric calculation. So well, in theory you can write a function to calculate sine and cosine. You can find the mathematical formula and implement them in your code. But well, the faster way to do it is to just call the math modules. In a math module, it also provide like the definition of pi, so you don't have to find pi. Maybe like you need it to be very accurate if you're calculating the sending a rocket to the Mars. Then you have to have very accurate calculation of pi. Then you don't have to go to look up pi up to, let's say, 25 decimal points and then put that in your code. You can just call the math module. Other things, for example, the JSON module that basically take in a string and then it will convert it into a dictionary, a string in JSON format to be precise. So when you read a JSON file, actually you can do it like by just using open a JSON file as a text and then reading all the text inside and parse it yourself to make it into a dictionary. But that's quite tedious, and people do that a lot. And we don't want to do that every single time when you have to write the code. So the JSON library provided all of these for you. Another common thing will be datetime. Datetime, people deal with them all the time, especially when you're working with data. You may also need to perform some kind of datetime calculation, like since this date, how many days have passed, or since this date, how many months have passed. So all these will need to use the datetime module to handle them to make your life easier. So these are just a few examples. I will also go into detail for some other modules that I want to introduce to you. The complete list of standard libraries are available on the Python documentation. By the way, now in the official Python documentation, there's also Spanish version available, and there's a big group of volunteers try to translate the English Python documentation into Spanish Python documentation. So if you're Duolingo, I guess some of you are, then you can go and help. I know the people working there. Unfortunately, myself, I cannot speak Spanish, but a lot of my friends, they are helping in the translation project, and it has been a very good progress. So what can I do if I want to create a virtual environment? So as hopefully a good developer myself, I like creating a new virtual environment every time I start a Python project. It's a good habit. I recommended all of the developers to do the same. But what if it's not available? Or, for example, I have encountered a situation that I'm giving a workshop and the attendees, they are beginners. They have no idea about virtual environment. It may be their first time using Python. Then it would be not very efficient if you ask people to install virtual environment managers, right? So I know there are a lot of Python virtual environment managers available out there, like Poetry, like Ppenv, and myself is like quite old-fashioned. I use a Pyenv virtual env wrapper. These are very good tool, but like I said, in situations that sometimes you can't install these managers, then actually Python come with one that you can already use. It's the venv module. So it's very easy. You create a new environment by just calling venv and then the name of the environment, and then you can just use the command source to find where it got stored. It's usually in the bin, and then you can just activate it. So that's really convenient for a lot of people. Another thing, especially for data scientists or people who work with CSV files, is the CSV module. So I know that we all love pandas, but what if pandas is not available? Or there are times that I just want to open a CSV file and have a look. I'm not doing a lot of data manipulations like you normally do with pandas. Then sometimes it's not worth installing a big library like pandas. You can just use the CSV modules to do that. So with the CSV modules, it will read in the CSV, and then it will give you back not a data frame, but you can actually get all the datas. Like you can think of it as cells, and then you can get them back with a for loop. So it will come in as a generator that you could loop with it with a for loop, and then get the content back. So in the CSV reader, you can put in a delimiter, which is the character that you use to separate different columns, different entries, and also you can specify a quote characters, which is sometimes if the delimiter is within the content of the cell, then you may have to quote it. You can also specify that as well. So it's a built-in parser. It's very lightweight. It doesn't do as much things as the Panda data frame can do, but at least you can read in a CSV file with less hassles. So another thing you can do for data scientists that you may use a SQL Alchemy to actually connect to your SQL database, and then to make queries. With SQL Alchemy, you have to also, download a driver specific to your database and then do the thing. Again, in our bank scenario, that's not possible. So what we can do is to use as SQLite 3. I think there's a typo there somehow, but oops. So yeah, it's SQLite. So okay, so this is the spelling. There's a typo in the slides, but yeah. So this is the library. Let me go back here. Right. So 1 second. Oops. Sorry about that. Let's resume. So yeah, there's a typo here, so ignore that. So this is the example code. So what you can do is to run a SQL query, you can just use the execute. It also provides a cursor for you, so it can connect to a database quite easily, and let you to make query, also commit the change, and so you can work with a SQL database quite easily. There's also API functionalities. A very popular one will be requests. So I think because requests is a very popular library, that there's also kind of a request equivalent in the URL library, URL lib. So in URL lib, you can do things similar to requests. You can make API call, or open a URL. So this is just like your get in requests, and then so you can just get back. So this is just like a get, and then you can get back what the call is, and then what result you get back. So it's quite powerful. Sometimes I use it together with requests, because sometimes I just want to pass the URL and pass the query like that. Then actually it's quite a the URL lib parse is quite a good tool to use. I would recommend that. So sometimes I use it together with the requests. So for developers, we know that test is very important. So one of the things that we do quite often is to write unit tests. Unit tests, I won't go into the detail, but it's kind of the idea of breaking your code into different units and then to test each part is working. So the whole program will work if every single part is working correctly. So normally the tool that I use is PyTest. It's very convenient. It's quite good. But if you can't use PyTest, then actually there's a UnitTest library that is included in the standard library. It works more or less like PyTest. It lets you write UnitTest and run UnitTest. So this is an example here. So it's just like PyTest, you write different tests with the test underscore. It works more or less the same. It's just that the output may be a little bit different from PyTest, and for some functionalities, maybe it's a little bit different. But a lot of the basic things, for example, like skip. I know this could could also work. In PyTest, you can skip a test, you can mark it fail. But in UnitTest, you can also you skip and then skip in certain cases and all this, which is very convenient. If you think about that, for example, this is a very good example showing that if the version is not right, then it may not worth running the test, because you know that it won't pass in that version. Or if some of the so you can see the conjunction, use it together with sys. So it checks some, whether your operation system is the desirable ones. If it's not, then maybe we won't run the test, because the test won't work for this operation system. So so there's something that is very good to do. So those are the common ones that you may came across, or you may actually found that useful in your project. There are also other things that are quite interesting that is included in the standard libraries. One of my favorite is a Pprint. So Pprint, the first P stands for pretty. So it prints things very prettily, not by adding emojis or making it fun, but it is designed to work with a dictionary. So if you have tried to print out a dictionary, then you know that it will just go in one line, which is very difficult to make sense of what it is. Because if it's a nested dictionary, then basically you don't know what is in there. With Pprint, you can or Pprint, you can see the nested structure. It will break the lines for you. It will indentate it, different entries with the comma here. You can it will break it for you, so you see that which structure is inside which structure. So it's very useful if you are dealing with a lot of dictionary, like my job, because I have to deal with a lot of dictionary myself. So Pprint is very useful, and I love it. There are other useful things. For example, Doctest. It will run the Python code in your doc strings, and then to see if it works. So it's very good to check whether your documentation have write the correct code. Because if you are like me, there's a lot of typos all the time. So it's not just testing that your code work, but also the example that you have given in your doc strings, which may be published in your documentation, to make sure that they are correct as well. So when people are reading the documentation of your library, then they know, the code example that you gave, they can run it and it will work. So it won't confuse them. So Doctest is quite useful in that case. Also PDB, another my favorite, is a debugger. So I know that a lot of you, me as well, a lot of times, that we debug by printing out what's going on. Because when you are testing a big chunk of code, you want to see what that variable, like what's the value of that variable. So then you can check whether that's correct or wrong. You can print it out, but that's not a very good practice, because you may forget where you put the print and clean it afterwards. Or sometimes there's a lot of things you may want to check, and then you may want to check this thing depending on the value of the first thing. So then you want a dynamic way of seeing what's inside when the code runs till that point. Then you can use PDB, which is a default Python debugger. You can add a set trace, basically a breakpoint in your code. So whenever your code runs to that point, it will stop and give you an interactive interface that you could check the value of that thing, or you can just type continue, so it will keep on running until it, for example, you put that the set trace in a for loop, then it will stop again when it go to that line again. So it's very helpful. Instead of printing a lot of values until it hits something you want to check, you can do it interactively. You can check, okay, this is all right, continue, and then again, okay, is this okay? Oh, this is not okay. What's going on? you may want to check some other things as well. So this is very useful. So instead of print, maybe we should all start to use PDV. Another funny thing is a tortoise. So tortoise, you may consider it not very useful because it's designed to draw pictures. So tortoise, as the name suggests, imagine you have a little tortoise that you can control it to go forward, to turn left, turn right, etc. It could also carry a pen that you can put it down and start drawing, or lift it up so it won't draw on the paper. So it's designed to teach kids how to program. It's like a mini game that is included in your Python. I think it's beautiful because it kind of let us not forgetting that the importance of education and to teach young coders or get more kids interested in coding. I think this is beautiful. So if you have a young child, like not too young, someone who is able to start coding or start using a computer, or then you could get them interested in Python by letting them play with tortoise. It's just come with Python. You don't need anything fancy. I think time is running out, so I gotta also suggest you check out these interesting standard library modules. So the first one is TimeIt. It's very useful, especially when you are dealing with, again, data use case. If you're dealing with a large amount of data, you may want to check some calculations, whether it's taking a long time or not. Then TimeIt is very useful. Then you can compare, maybe there's a better way to write the code, do the calculation that save some time when you are dealing with a lot of data. Subprocess is again very powerful. I use it a lot when I have to run my database backend in a Docker container. I can use subprocess to run Docker because if you are familiar with Docker, Docker can be run in a shell command. So with subprocess, I can run that shell command directly from a Python script. XML is useful when you are dealing with XML file. So like someone like me who need to measure a lot of data coming in and out in different formats, you may came across XML format, and then it is like the CSV modules that I have mentioned earlier that lets you parse XML files with less stress. Also async IO, which lets you do a lot of async operation. So regarding async, I have actually made a Twitch tutorial in the past, so you can find that on my YouTube channel. So I won't go into detail here. Import lib, I realized that I use it quite a lot because a lot of times I have to dynamically import a file or a module depending on the situation, depending on someone's input. So input lib let you do that instead of importing it from the start. You can just import something during runtime. RE means regex, so just regular expression. So it's very useful when you're dealing with a lot of text. Again, if you're someone dealing with data, if there's some text that you want to find the pattern of it, then RE is very useful. File CMP are used to compare files. Again, useful when you're dealing with files of data. There are also other tools that I don't use a lot personally, but seems quite interesting. There's actually the Tinker, which is a GUI tool. I haven't tried it out yet, so I can't comment on it. There's also other parallelism tool that like threading and multiprocessing that I don't have a chance to try them yet. If you have tried any of those, feel free to let me know or let others know what you think about them. So which one is your favorite? Now it's open for discussion. We can talk about that during the conference. And then if you met someone and you want to start talking with them to start a conversation, you can ask them which one is your favorite standard library. And then you can make a friend because of that. So thank you so much for listening to my talk, and I hope you enjoyed the rest of the conference.